All right, this is Math 103, 7.3 notes on mass and temperature. And so there's a little information here at the beginning that talks about mass and the difference of mass. And technically, they're not the same, okay? So mass is like your body structure. And that is going to be something, the matter that makes up your object. Okay, that is what is referred to as mass. It's determined by the molecular structure and it doesn't change usually from place to place. So if we were, here on Earth, which we are, our mass is going to be the same as it's going to be if we were to go to the moon. Our mass does not change. It's the molecular structure of our body. However, weight is a measure of gravitational pull on that object. So if we were to weigh ourselves on Earth and then weigh ourselves on the moon, we would be a lot lighter on the moon because the gravitational pull is not the same. And so, but for our purposes, because we're not going to be doing anything on the moon, our purposes, mass and weight are going to be the same. It's going to be interchangeable with each other. And so if I use the word mass, I use the word weight, we're going to be basing our information on the gram or the kilogram. Now, I said that the gram was our base unit in measurement, but they're saying that the kilogram is going to be our biggest measurement. So like when we weigh things in pounds, okay? And the kilogram is going to be anything that you're going to weigh in terms of pounds, okay? The gram is a lot smaller. And the gram is 0.001 of a kilogram. It's relatively small. And so things that we would measure in ounces, such as like cereal, or, baby formula or something like that, a scoop of, hot cocoa, those would be things that we would be measuring in ounces, okay? And so we're going to use the gram. The milligram is extensively used for the scientific and medical field. So, when we get a pill or a tablet, it's usually 5 milligrams. And that's going to be a measurement that we're going to look at in the, pharmaceutical industry is going to be a very common measurement. Then in English, we have a ton, okay? And so in the English system, we have a ton, which is represented with capital T, and that is 2,000 pounds, okay? In the metric system, we have what is called a metric ton, and it's spelled tonne, T-O-N-N-E, and that is a little t, and that's used to express very heavy, large items, okay? A metric ton is 1,000 kilograms. So we're now going to add a little word to our King Henry died by drinking chocolate milk, and that'll be at the end of this section. So, these are our measurements. So in this example, they're going to ask you, what measurement out of a metric ton, a milligram, a gram, or a kilogram would be the best way to measure these items, okay? And so, again, think of things that you would measure in pounds, such as a 1-year-old child. That would be measured in kilograms. A refrigerator would probably be measured in kilograms. A laptop computer could be grams or kilograms. So we'll put G or kilograms here. Now, if we measure things in ounces, those are going to be grams. So a box of cereal would be grams. A frog would be grams. A calculator would be grams. Then we're going to think of very, very light objects or small doses of medicine. So a spider would be a milligram, and then a locomotive would be a metric ton. Okay, so that would be our largest unit. So we have these units here where we have volume in cubic units, we have volume in liters, and then we have mass in water. So these going to be interchangeable, and these information points will be given to you when you're asked to change something to a different unit. Now, if we were to select the best answer for these next problems, the mass of a bag of topsoil would be something probably in pounds. So we would say that would be about 18 kilograms. Okay. The mass of a donut, that would be something probably in ounces, would be about 20 grams. The mass of a coffee pot filled with coffee, that's going to be about 1.4 kilograms. The mass of a bathroom scale would also be 1.8 kilograms. The mass of a full-grown rhinoceros, that's going to either be metric tons or kilograms. And then the mass of a full-size car, we would say 1.6 tons, metric tons, okay? Now, getting to the application problems, we're now going to see that in this one we have units of all different lengths. We have meters, we have we have centimeters, and then we have millimeters. So I'm going to convert all to meters, okay? So 1 meter long, well, that's already converted. So 50 centimeters. And if I do King Henry died by drinking chocolate milk, 50 centimeters is right here. And we go 1, 2 to the left. So that becomes 0.5 meters. And then we've got 250 millimeters. We go 1, 2, 3 to the left. That becomes 0.25 meters. Okay, so the volume in cubic meters is 1 meter long, 0.5 meters wide, and 0.25 meters high, or I said that backwards, but same thing. And we will get 0.125 meters cubed, okay? But that's not what they're asking. They want to convert it to liters, okay? So if we look at that reference chart, we go back and we can see that 1 meter cubed right here is equivalent to 1 kiloliter. Okay, so 1 meter cubed is equal to 1 kiloliter. So we have 0.125 meters cubed, which says we have 0.125 kiloliters. And now we're going to use our King Henry died by drinking chocolate milk. Kiloliters to liters goes 1, 2, 3 to the right. So 0.125 kiloliters is equal to 125 liters. And that's the first question that they want you to answer. Then it says, what is the mass of that water? Well, if you look on that same table, 1 liter is equivalent to 1 kilogram. And so we have 125 liters, which means we also have 125 kilograms. Okay, so now going into temperature, we should have some reference points on your thermometer, and it's always a good idea when you look, you can see 0 degrees Celsius is our freezing point, 32 degrees Fahrenheit, okay? So you get some Celsius temperatures here that match up to your Fahrenheit temperatures on the right. And so choosing the best option in Chicago on New Year's Day, which would be very cold, would be negative 10 degrees Celsius. So negative 10, it looks like it's about 12 or 15 degrees on the Fahrenheit side. If you just kind of look, there's the negative 10, and you look to the left, that's the Fahrenheit. Baltimore on July 4th, which is very hot, would be 30 degrees Celsius. And 30 degrees Celsius, that's about 85-ish, 188 degrees, okay? The oven temperature for baking a cake is usually about 350. So we look, and that's probably going to be 175 degrees Celsius. Now, I am going to write these formulas. I think it's a lot easier to use decimals instead of fractions. So I'm going to change these formulas like this, where I am going to multiply by 1.8 to convert Celsius to Fahrenheit, or I'm going to divide by 1.8 because 9/5 is 1.8. And if I multiply by 5/9, that is the same as dividing by 9/5, dividing by the reciprocal. So those formulas I find are a lot easier to work with. So to convert this Celsius temperature, we have 55 degrees Fahrenheit. We subtract 32, and then we divide it by 1.8. I'm going to caution you to make sure you either hit equals or put parentheses around that so that you get the correct answer of 12.8 degrees Celsius. On the next one, we're going from Celsius to Fahrenheit. So in that instance, Fahrenheit is 1.8 times 60 plus 32, and that comes out to be 140 degrees Fahrenheit. Okay. All right, so now we're going to do these three. So if I've got 0 Fahrenheit, and I want to convert that to Celsius. So we take 0 minus 32 divided by, nope, sorry. Yeah. 0 minus 32 divided by 1.8. So that gives me negative 32 divided by 1.8. And that comes out to be negative 17 point, and we'll just round it to 1 decimal point, negative 17.8. All right, 100 degrees Fahrenheit, we want to change that to Celsius. So 100 minus 32, then divided by 1.8. And that comes out to be 37.8. And now we're going to go the opposite direction. We're going to take our Celsius. So Fahrenheit is 1.8 times the Celsius temperature, adding 32. And that's going to be 98.6. And then Fahrenheit would be 1.8 times negative 4 plus 32. And that comes out to be 24.8. All right, so the special examples, these are going to be the ones that I'm going to add that special saying. So remember, we have King Henry died by drinking chocolate milk. And now we're going to add the King Henry. And this T represents the metric ton. And so remember, we said on that previous page, or on one of those pages, we said that 1 metric ton was equivalent to 1,000 kilograms. So if we're going from this step to kilogram 1, 2, 3, we have to move 3 places to the right or the left, depending on what direction we're going, okay? So sometimes I do stair steps, or sometimes I just put that word, but and put the, and then I count each letter. So if we're starting at kilograms, okay, we're going to start here, and we're going to go 1, 2, 3. We're going to move that 3 places to the right. So that becomes 0.0062, okay? if we are going from tons, which is here, to grams, which is the base, 1, 2, 3, 4, 5, 6. We have to move it 6 places to the right. So that's going to become 174 followed by 5 zeros. So 17,400,000. Okay. So we've got milligrams. So we're starting all the way down here. Milligrams. 1, 2, 3, 4, 5, 6, 7, 8, 9. We are going to move it 9 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we will have 0.00146. And then last but not least, we will go from tons, which is the T, to kilograms. 1, 2, 3 to the right. So that will be 9,520. And that finishes 7.3.